On April 7, 1945, the dawn horizon over the Central Pacific revealed a volcanic landscape shaped by ancient forces, creating an island whose strategic value outweighed its barren hostility. American planners recognized that Iwo Jima's jagged ridges overlooked air routes used by B-29 bombers, forcing them to confront a fortress environment defended by determined Japanese forces. February 1945 marked the beginning of an operation defined by attrition, where Marines fought yard by yard through black ash that concealed intricate tunnel systems. The Japanese commander General Kuribayashi understood his isolation. However, he resolved to inflict maximum casualties through a defensive strategy built on depth rather than beaches. Marines advancing across the terrain faced concealed machine gun nests positioned within hardened positions, ensuring every movement required coordination shaped by bitter frontline experience. The need for airfields on Iwo Jima drove every assault because long-range fighter escort remained impossible without a forward base carved from the volcanic plateau. Mount Suribachi dominated the southern approaches, yet its capture represented only the first step within an operation stretching across weeks of relentless combat. American engineers followed closely behind assault units, racing to stabilize terrain that shifted under pressure, complicating efforts to establish usable runways under fire. The determination to secure Iwo Jima stemmed from analysis showing how emergency landings increased among bombers returning from Japan, creating unacceptable losses during extended missions. Capturing this island promised sanctuary for crippled aircraft, offering a critical safety margin required for sustained bombing operations conducted across unforgiving geographic distances. Japanese defenders exploited every natural advantage offered by caves and ridges, delaying American progress while inflicting significant casualties through concealed artillery fire. However, American logistics and firepower eventually eroded these defensive networks, demonstrating how persistence combined with overwhelming resource superiority shaped battlefield outcomes. By early March, the island's southern airfield neared operational status, allowing initial fighter deployments despite ongoing Japanese resistance across northern sectors. Pilots landing on newly carved runways faced explosive hazards created by sporadic attacks, necessitating constant vigilance shaped by unpredictable battlefield dynamics. Flying units quickly adapted to conditions dominated by volcanic dust, which infiltrated mechanical systems, challenging maintenance crews tasked with preserving aircraft readiness. The strategic implications of Iwo Jima's capture extended far beyond local terrain, because this island opened a corridor enabling unprecedented fighter escort operations. This transformation emerged from calculations showing that single-engine fighters equipped with extended fuel capacity could potentially reach Tokyo from this forward base. Though theoretical models suggested feasibility, no nation had executed such missions across oceanic expanses, requiring unwavering navigation discipline and extreme pilot endurance. The sacrifices endured during the island's capture established the foundation for these missions, proving how determined investment in strategic objectives shaped broader war trajectories. American commanders understood the island's significance, recognizing that its airfields would enable an aviation breakthrough poised to alter the course of the Pacific conflict forever. American engineers arriving on Iwo Jima confronted terrain fundamentally hostile to construction, because the island's volcanic sand collapsed beneath every vehicle that attempted movement. Bulldozers sank into shifting ash that undermined progress, forcing crews to invent stabilization techniques while artillery fire echoed across ridgelines, still held by Japanese defenders. The island's sulfuric fumes drifted continually from underground vents, creating a noxious atmosphere that irritated eyes and lungs, complicating tasks requiring prolonged concentration under pressure. Naval construction battalions known as Seabees worked beside Marine units, shaping runways despite sniper attacks originating from hidden positions embedded within the complex cave networks. Each section of cleared ground required layered reinforcement, demanding crushed rock hauled from improvised quarries, added methodically to surfaces that resisted compaction under conventional methods. Progress unfolded slowly because engineers balanced speed with survivability, understanding that incomplete surfaces risked aircraft disasters, capable of crippling future operations centered on long-range missions. While airfield construction proceeded, Japanese holdouts launched sporadic infiltration attempts, forcing security teams to maintain constant patrols across unfinished sectors illuminated by makeshift lighting. Maintenance personnel arrived early to prepare for incoming fighters, establishing fuel depots and dispersal bays despite volatile weather patterns that accelerated erosion across exposed locations. The first functional runway emerged from this arduous environment, enabling transport aircraft to land supplies essential for continued expansion required to support forthcoming fighter groups. As additional infrastructure formed, planners coordinated the arrival of P-51 units, ensuring that each squadron received hardened parking areas designed to withstand strafing attempts. The airfields needed to handle unprecedented operational demands because the planned missions demanded maximum fuel loads dependent on precisely maintained surfaces for safe takeoffs. Engineers reinforced runway edges using interlocking steel mats, creating stability where natural materials failed, demonstrating adaptive problem-solving driven by relentless operational necessity. Day and night workloads remained continuous as pump stations, repair sheds, and storage facilities materialized amid the constant rumble of artillery duels across northern sectors. Crews often labored wearing gas-impregnated cloths around their faces, protecting themselves from sulfur emissions that intensified around low-pressure pockets scattered across the ground. Despite hazards, morale stayed focused because crews understood that their work enabled fighter escorts capable of safeguarding bombers journeying deep into Japanese airspace. Every completed taxiway represented another step toward operational independence, allowing aircraft to maneuver efficiently despite limited space carved from unforgiving volcanic terrain. A network of communications lines soon connected control towers with maintenance teams, supporting coordinated launches essential for missions demanding strict timing precision. Fuel storage required special attention because volatile temperatures affected stability, prompting construction of revetments shielding tanks from bombardment and natural heat absorption. By mid-March, the airfields neared full operational capability, marking a turning point where engineering triumphs overcame natural and tactical obstacles encountered since the landings. These newly forged runways stood as testament to determination, providing the foundation from which the longest single-engine fighter missions in aviation history would soon be launched. The pilots assigned to Iwo Jima's long-range missions represented a generation shaped by rapid wartime training, carrying limited experience with advanced aircraft. Most had transitioned from earlier trainers into P-51 Mustangs within remarkably short periods, absorbing complex systems while adjusting to unfamiliar handling characteristics. The Mustang's Packard Merlin engine introduced power levels far beyond previous platforms, demanding respect from aviators still refining their instincts under demanding operational schedules. Flight instructors emphasized discipline because long-range escort duty required precision flying, leaving no margin for improvisation across thousands of miles of open ocean. Navigation lessons became critical, teaching pilots to rely on magnetic headings, drift calculations, and estimated winds, which collectively determined survival during extended over-water travel. Each aviator practiced fuel management techniques designed to stretch operational limits, balancing throttle settings with altitude considerations that directly influenced consumption rates. Simulated missions instructed pilots to fly in formation while maintaining stable parameters, demonstrating how even slight deviations risked fuel shortages during later combat engagements. Radio procedures received equal attention, requiring calm communication maintained across hours of flight, supporting coordination among escorts and bombers operating within complex formations. Training officers highlighted the dangers posed by weather because unpredicted fronts often appeared without warning, forcing pilots to evaluate cloud formations with practiced judgment. Ground crews worked alongside pilots to familiarize newcomers with maintenance constraints, teaching them how volcanic dust threatened engine reliability and cooling efficiency. The learning curve accelerated once squadrons reached Iwo Jima, where the pressure of operational necessity compressed instruction into tightly controlled timetables. Pilots practiced emergency procedures repeatedly, understanding that ditching in the Pacific offered slim chances of survival despite trained rescue units positioned along mission routes. Psychological endurance became a central component of training because missions required prolonged concentration, producing fatigue capable of impairing decision-making during critical moments. Instructors drilled fuel transfer operations, reminding pilots that improper usage of internal tanks destabilized aircraft balance, complicating control during initial climb phases. Gunnery exercises practiced altitude advantage tactics, instructing aviators to strike from above using boom and zoom principles rather than traditional turning engagements. The importance of formation integrity dominated briefings, emphasizing how the protection of B-29 bombers depended on consistent spacing, altitude discipline, and mutual support. Young pilots quickly recognized the Mustang's strengths, appreciating its speed, climb rate, and stability, which collectively offered confidence while approaching heavily defended targets. However, they also confronted its limitations, learning that overloaded aircraft carrying extended fuel required careful handling until drop tanks were released before combat. Daily practice flights traced long arcs across the ocean, providing experience with unfamiliar horizons lacking visual references, strengthening reliance on instruments under changing conditions. By mission readiness, these young aviators embodied a new breed of long-range fighter pilot, prepared for unprecedented operations that demanded resilience, precision, and absolute dedication. The transformation of the P-51 Mustang from a tactical fighter into a strategic escort platform began with its revolutionary Packard-built Merlin engine. This powerplant delivered remarkable high-altitude performance, allowing pilots to accompany B-29 formations operating above 20,000 feet where thin air challenged competing designs. Engineers recognized that achieving extreme range required more than mechanical excellence, demanding innovations in fuel carriage that would reshape operational possibilities across the Pacific. Drop tanks emerged as the decisive solution, providing additional capacity while preserving the Mustang's maneuverability once released during imminent combat encounters. Each external tank carried fuel stored within lightweight structures, designed for rapid jettisoning when pilots needed immediate access to maximum performance during hostile engagements. The integration of these tanks required reinforcing pylons and careful aerodynamic testing, ensuring stability across extended flights influenced by constant weight distribution changes. Engineers balanced durability with minimal drag, accepting minor vulnerability to gunfire because the tanks were intended only for outbound travel preceding combat phases. Test pilots evaluated various configurations, measuring consumption rates and determining optimal altitudes, which collectively shaped procedures adopted for operational missions departing Iwo Jima. The fuselage tank added another reservoir positioned behind the pilot, requiring caution because its usage altered aircraft balance during initial mission segments. Pilots learned to consume fuselage fuel early, re-establishing stability before entering maneuver-intensive environments where agility determined survival against determined interceptors. The combined fuel system expanded effective radius dramatically, allowing Mustangs to escort bombers across vast distances previously considered beyond any single-engine aircraft. Flight engineers created standardized checklists guiding tank transitions, ensuring predictable consumption patterns that supported navigational accuracy during long journeys lacking visual cues. Strategists recognized that extended range allowed American forces to project air power directly over Japan, undermining assumptions regarding homeland sanctuary maintained by imperial planners. Drop tanks enabled pilots to complete 8-hour missions, demanding confidence in engineering solutions refined through rigorous testing, shaped by evolving battlefield requirements. Maintenance crews inspected attachment points daily, understanding that any failure threatened aircraft survival, especially during initial climb where tanks bore significant aerodynamic stress. The system's simplicity became its greatest strength, relying on mechanical reliability rather than delicate components vulnerable to field conditions shaped by volcanic dust. During combat, the moment pilots released their tanks marked a transformation, shifting from heavy endurance platforms into agile fighters optimized for decisive action. This duality allowed Mustangs to preserve energy for engagements, ensuring they met Japanese aircraft with speed and altitude advantages derived from superior engineering. The strategic impact extended beyond individual sorties, because long-range escorts allowed bombers to strike with reduced losses, accelerating the collapse of Japanese industrial capacity. Through ingenuity and precision, engineers turned the Mustang into a weapon capable of reshaping the Pacific Air War, proving that innovation could overcome geographic constraints. April 7, 1945 began beneath low drifting clouds over Iwo Jima, as 96 Mustang fighters prepared for history. Each pilot moved with solemn precision while ground crews completed final checks, because every mistake threatened thousands of miles ahead. Engines ignited across the newly carved airstrips, sending trembling vibrations through volcanic ground shaped by recent battles. The departing aircraft represented the first fully coordinated long-range fighter strike launched directly toward Tokyo from this captured island. The Mustang formations lifted into the gray morning sky in disciplined groups, gathering altitude steadily while maintaining strict fuel discipline. Every pilot understood that mismanaging drop tanks early meant catastrophic consequences far from any possible rescue. Their mission combined escort obligations with offensive interdiction duties, creating an unprecedented operational burden requiring flawless teamwork across extended distances. Navigational checkpoints were plotted carefully across the Pacific expanse, because deviation meant vanishing into an ocean offering no forgiveness. As they advanced northward, the pilots monitored engine temperatures and manifold pressures continuously to ensure stable performance during prolonged high-power cruising. The Merlin engines produced consistent thrust despite gathering turbulence, confirming remarkable engineering resilience under uniquely demanding circumstances. Radio calls remained sparse but decisive, maintaining operational silence while allowing course adjustments determined through mathematical calculations. Every formation anchor maintained absolute vigilance regarding spacing, because aerodynamic inefficiency translated directly into unacceptable fuel losses. Midway through the transit, sunlight pierced thinning clouds, revealing endless blue distance without features to assist orientation. The pilots relied entirely on instruments and dead reckoning techniques, refined during rigorous training sessions on Iwo Jima. Their endurance limits were tested continuously, because physical fatigue mounted steadily throughout this harsh journey. Tight cockpit spaces offered minimal relief, forcing every pilot to control discomfort while preserving complete situational awareness. Still, the discipline instilled through near-relentless preparation ensured calm judgment remained dominant across the entire strike group. Approaching the Japanese coastline, the Mustangs descended gradually to predetermined altitudes, supporting mutual protection while preserving fuel margins required for combat engagement. Below them stretched the approaches toward Tokyo, veiled partially by industrial haze generated through years of intensified wartime production. The pilots sensed an immense historical threshold because their arrival marked a transformation in air strategy challenging previous assumptions. Their role extended beyond ordinary fighter missions, since they represented a new capability altering strategic calculations across the Pacific theater. As they continued toward designated objectives, the sun climbed behind them, illuminating silhouettes carrying enormous responsibility. Every Mustang embodied determination forged through sacrifice and innovation, because no previous fighter force had attempted such ambition. The significance of their departure from Iwo Jima resonated profoundly, shaping evolving doctrines defining long-range air warfare. The pilots watched fuel gauges carefully while adjusting propeller settings deliberately, because every decision influenced endurance essential for the long-approaching rendezvous. Their instruments displayed slight fluctuations caused by shifting atmospheric pressures, yet disciplined corrections preserved formation integrity throughout the demanding ascent phase. Below them, Iwo Jima receded into distant haze, symbolizing an island transformed into a critical operational platform enabling unprecedented aerial coordination. Each pilot felt increasing responsibility because the mission required joining Superfortress bombers crossing immense distances previously considered uncontrollable by escort fighters. Far ahead, the B-29 stream moved along its assigned route with unwavering purpose, carrying ordnance destined for strategic industrial zones. The Superfortresses maintained immense cruising altitudes demanding persistent climbs from the accompanying Mustangs, testing aircraft performance under continually thinning air. Engine temperatures required constant monitoring because high-altitude operations strained cooling systems designed originally for shorter engagements across continental environments. Despite these challenges, the formations advanced steadily while recognizing the profound significance of merging two technologies across a single synchronized operation. Their objective extended beyond simple protection because this union demonstrated emerging doctrine shaping the evolution of American long-range air dominance. As the fighters approached the rendezvous point, faint metallic silhouettes appeared gradually against brilliant sunlight filtering through fragmented cirrus clouds. The B-29 crews observed approaching Mustangs with visible relief because previous missions lacked dependable escort coverage across hostile skies. Radio coordination remained minimal yet precise, allowing each unit to assume designated positions without disrupting carefully structured bomber navigational patterns. The Mustangs slid into protective arcs around the larger aircraft, forming interlocking screens capable of repelling interceptors before they threatened primary targets. Every pilot understood this geometry represented a deliberate transformation in airborne strategy, enabling offensive campaigns previously limited by technological constraints. Once established, the combined force advanced toward Japan with steady confidence because mutual support enhanced resilience across the extended mission profile. The bombers offered stable reference points, aiding navigational accuracy, while the fighters provided flexible maneuver capabilities essential for responding instantly to threats. Altitude-induced discomfort grew increasingly severe, forcing pilots to rely on oxygen equipment delivering continuous flow necessary for sustained clarity. Still, their discipline preserved operational effectiveness because earlier training on Iwo Jima ingrained habits preventing physiological deterioration during prolonged exposure. The merged formation represented an evolving partnership reflecting countless lessons extracted from earlier campaigns over Europe and the Pacific. Approaching the enemy coast, every pilot scanned distant horizons for contrails or angular glints, indicating rising interceptors preparing coordinated attacks. The Mustangs distributed themselves across layered positions, ensuring overlapping fields of fire capable of disrupting Japanese tactics reliant on rapid climbs. Bomber crews monitored defensive gun emplacements while trusting their escorts to counter threats before hostile formations achieved advantageous approach angles. Even minor adjustments demanded exceptional precision because miscalculations at altitude could fracture delicate balance, maintaining formation cohesion across vast skies. The combined group moved like a single organism, demonstrating an unprecedented level of synchronization defining the nature of modern aerial warfare. As Japanese fighters emerged sporadically, the Mustangs accelerated instantly, breaking from protective arcs before re-establishing coverage with meticulous efficiency after each engagement. Their attacks forced interceptors into chaotic defensive maneuvers, disrupting coordinated strikes intended to concentrate fire against vulnerable bomber elements. The B-29 crews reported significant reductions in sustained pressure compared to previous unescorted missions endured during earlier phases. This synergy confirmed that long-range escort deployments fundamentally altered combat dynamics, diminishing enemy opportunities for concentrated offensive success. Each completed interception reinforced confidence across the formation because their combined presence reshaped battlefield expectations entirely. The bombers continued methodically toward industrial districts surrounding Tokyo while the fighters adapted continuously to shifting altitude and temperature conditions. Every Mustang pilot measured fuel reserves with increasing vigilance because return legs across ocean expanses offered no margin for error. Still, their determination remained steady because the mission embodied months of planning culminating in fully realized strategic cooperation. B-29 navigators updated course corrections precisely, ensuring the strike maintained timing essential for coordinated delivery across multiple sectors. The escorting Mustangs guarded every adjustment, reinforcing collective discipline essential for completing historically significant operations demanding absolute cooperation. During bombing runs, the sky erupted with flak bursts, scattering dark fragments across thin atmosphere surrounding the Superfortresses moving steadily forward. The Mustangs wove protective paths through drifting debris patterns while maintaining vigilance against opportunistic fighters seeking vulnerable angles. Despite turbulence and explosive shockwaves, the bombers held their lines because escort presence reduced psychological pressure dramatically. The coordinated force delivered ordnance with accuracy achieved previously only during missions supported by overwhelming numerical advantages. This achievement represented culmination of engineering advances, logistical innovations, and evolving doctrines crafted through relentless wartime necessity. As the formation turned seaward, the fighters regrouped gradually, reforming screens designed to shield retreating bombers throughout the long return journey. Fuel levels tightened significantly, forcing every pilot to adopt disciplined throttle settings calculated to sustain remaining operational range. The bombers descended slightly to stabilize airflow across fatigued engines while maintaining defensive vigilance against isolated pursuing aircraft. Though exhaustion pressed heavily across every cockpit, the escort fighters maintained cohesion, reflecting unwavering commitment to mission integrity. Their return marked successful demonstration of groundbreaking strategic capability, capable of altering trajectories of future campaigns dramatically. The Mustangs finally sighted volcanic shorelines stretching across horizon, signaling conclusion of an operation redefining parameters of aerial escort doctrine. The bombers continued separately toward rear bases while the fighters circled downward through layered winds sweeping across Iwo Jima. Ground crews observed returning aircraft with visible pride because their tireless labor enabled missions previously considered beyond technological reach. As wheels touched blackened runways, pilots recognized they had participated in a watershed event transforming perceptions of fighter versatility. This achievement established foundation for modern strategic aviation, proving long-range escort warfare could dominate even the largest operational theaters. Saburō Sakai, already renowned for extraordinary combat instincts, launched with veteran composure while evaluating rapidly changing strategic conditions. He understood earlier advantages depended on nimble Zero fighters capable of decisive maneuvers. Yet shifting circumstances threatened established doctrines. The appearance of Mustangs from newly secured Iwo Jima introduced performance margins exceeding anything frontline pilots previously encountered. This transformation created unprecedented tension because Japanese tactics relied on initiating engagements through superior climb rates and rapid acceleration. As the formations climbed steadily, Sakai observed distant glints cresting horizon lines, revealing aircraft shapes unfamiliar to many squadron members. Their silhouettes displayed elongated wings and deep radiators, indicating powerful engines capable of sustaining extended high-altitude operations. Sakai maneuvered for altitude advantage carefully because traditional Japanese doctrine emphasized controlling vertical positioning before committing to attack. However, the approaching Mustangs climbed relentlessly, maintaining velocity during ascent phases that previously exhausted lighter Zero airframes rapidly. This imbalance challenged assumptions embedded within training programs developed during earlier years, dominated by Japanese aerial supremacy. The initial merge unfolded with astonishing acceleration as Mustangs swept forward using superior engine torque, enabling immediate directional authority. Sakai attempted evasive spirals relying on tight turning capabilities, yet the pursuing fighters preserved energy throughout sustained pursuit arcs. This unprecedented behavior shocked experienced aviators because Zero fighters traditionally regained initiative through superior maneuverability across tight radii. Instead, the Mustangs dictated engagement tempo entirely, shifting between vertical climbs and slashing dives beyond reach of counteraction. The resulting dynamic revealed technological displacement, overwhelming aggressive tactics refined across countless earlier campaigns. During brief separation windows, Sakai evaluated structural design elements enabling such dominance, recognizing supercharged Merlin engines as decisive factors. Their capacity to deliver stable power across varied altitudes removed vulnerabilities limiting Japanese fighters reliant on older compression systems. Additionally, the Mustangs carried substantial fuel loads supported by advanced tank configurations, allowing deep penetration into contested territories. This endurance transformed battle geometry because Japanese pilots faced opponents capable of sustaining presence through entire operational windows. Sakai realized these advantages eroded interception strategies dependent upon forcing attrition through repeated sortie waves. As the dogfight resumed, Mustangs executed coordinated teamwork, forming layered protective screens that eliminated opportunities for isolated breakthroughs. Their discipline contrasted sharply with Japanese formations weakened by attrition, limited training reserves, and eroding logistical foundations. Sakai recognized declining national resources prevented upgrades necessary to counter emerging Allied capabilities with comparable technology. Every maneuver confirmed widening gap between wartime doctrines derived from 1942 and realities emerging by 1945. The psychological impact proved profound because surviving veterans understood they were confronting irreversible strategic imbalance. Mustang pilots exploited speed differentials enabling disengagement at will, undermining Japanese reliance on sudden close-range strikes. Their ability to convert altitude into momentum protected them from classic zero-turning traps once considered decisive battlefield advantages. Even expert pilots like Sakai struggled to initiate meaningful counterattacks because energy retention dictated outcomes before maneuvers began. The Zero's lightweight construction enhanced agility but offered minimal protection under concentrated fire delivered with remarkable precision. This contrast highlighted structural gaps created by divergent industrial priorities, shaping each nation's wartime aviation programs. As engagements expanded, Japanese ground controllers reported increasing losses because new, Allied escort tactics protected bombers while dominating surrounding airspace. Sakai observed formations collapsing under cumulative pressure, revealing unsustainable attrition rates accelerating decline of operational readiness. Younger pilots lacked experience necessary to survive extended battles against technologically superior adversaries with extensive training pipelines. Veteran guidance mitigated some losses, yet could not compensate for equipment limitations determining outcomes across most encounters. The Mustangs represented convergence of industrial power, engineering innovation, and tactical evolution, overwhelming opponents through relentless efficiency. In rare moments of escape, Sakai reflected on earlier triumphs achieved during eras defined by Japanese initiative and tactical ingenuity. He understood changing conditions demanded adaptation, yet wartime circumstances prevented development timelines required for competitive replacements. Attempts to counter long-range escorts with specialized interceptors faltered due to resource shortages crippling manufacturing capacity. The once dominant aviation force now confronted adversaries deploying fighters designed specifically to neutralize earlier Japanese advantages. This realization deepened sense of inevitability permeating strategic outlooks across surviving combat units. Even so, Sakai demonstrated remarkable perseverance by exploiting remaining strengths, executing precise defensive maneuvers, enabling occasional evasion. He relied on instinctive timing developed through extensive experience, leveraging zero responsiveness during fleeting opportunities for disengagement. Yet every success underscored broader reality that tactical skill could not overcome, widening technological disparity shaping every engagement. The Mustangs returned repeatedly with undiminished vigor, sustained by logistical networks enabling consistent frontline presence. Sakai accepted these conditions with stoic realism, acknowledging shift marking definitive end of earlier Japanese aerial dominance. Their presence symbolized transition toward modern air supremacy rooted in range, speed, firepower, and operational integration. The struggle demonstrated that national survival depended on industrial strength, supporting technological innovation beyond individual valor. For Sakai, the encounter became a defining moment, illustrating culmination of strategic decline accelerating throughout final war year. This development eliminated opportunities for decisive defensive actions capable of halting sustained strategic bombardment. The shock of encountering Mustangs confirmed irreversible trajectory, leading toward collapse of remaining resistance. He emphasized that air combat truth lies within physics and engineering rather than mythology surrounding individual heroism. Sakai's testimony therefore provides invaluable insight into transitional period linking early war improvisation with late war sophistication. Dawn on April 7, 1945 revealed distant contrails weaving across Tokyo Bay as Japanese Air Command prepared defensive responses cautiously. American formations approached with absolute precision, maintaining disciplined spacing while climbing steadily into strike corridors that Japanese planners once considered entirely unreachable. The Mustangs closed rapidly, using altitude advantage to impose immediate pressure on defenders already strained by losses suffered in prior engagements. Their tactics emphasized coordinated aggression, relying on slash-and attacks executed from superior energy states impossible for Japanese fighters to counter properly. This approach combined calculated speed with strict formation integrity, creating synchronized strikes that fractured defensive cohesion before countermeasures could mobilize effectively. Japanese interception doctrine relied heavily on massed formations, attempting swift climbs toward bombers approaching vulnerable sectors above the capital region. These procedures faltered instantly once Mustangs swept ahead, disrupting assembly patterns by forcing pilots into reactive maneuvers that destroyed timing. Every defensive plan depended on accurate anticipation. Yet American fighters exploited surprise through altitude transitions executed with remarkable fluidity and discipline. Their boom and zoom methods shattered expectations, demonstrating that speed delivered overwhelming advantage against opponents bound to outdated tactical frameworks. Consequently, defenders found themselves isolated, scattered, and unable to regain coordinated momentum once initial contact dissolved planned counterattacks entirely. Over industrial districts thick with smoke, the Mustangs established rotating screens that intercepted any climbing aircraft attempting desperate approaches. Each element focused on maintaining constant visual control, enabling swift transitions whenever Japanese fighters tried exploiting gaps between protective layers. This system formed an aerial barrier preventing Zero pilots from executing their preferred turning engagements designed to exploit agility advantages. The Mustangs deliberately avoided low-speed turning contests, instead choosing vertical maneuvers that forced opponents into disadvantageous positions repeatedly. Through this method, American fighters dictated engagement rhythm, absolutely, collapsing Japanese attempts to reset battle geometry through rapid regrouping. As smoke columns rose across Tokyo, the B-29 formations pressed forward confidently, protected by escorts that absorbed every hostile attempt. Mustang pilots maintained flexible attack patterns, prioritizing energy retention, which allowed them to re-engage instantly after each swift pass. Japanese aircraft trying head-on attacks discovered escort screens positioned deliberately to break formations before they reached bomber perimeters. Every disrupted pass further reduced momentum, reinforcing American dominance as defenders gradually lost situational control within chaotic sky conditions. This collapse underscored effectiveness of long-range escorts integrated seamlessly into bombing operations requiring sustained airspace superiority. Throughout the battle, Mustang discipline remained absolute, showcasing adaptability derived from rigorous training emphasizing fuel management and coordinated maneuver execution. Their ability to sustain pressure across extended distances revealed operational depth unmatched by Japanese units struggling with attrition. Japanese observers realized defensive doctrine rooted in close-range combat had become obsolete once confronted by energetic adversaries. The Mustangs demonstrated that air superiority required technological endurance combined with tactical flexibility capable of overwhelming rigid defensive structures. By nightfall, Japanese air defense doctrine lay irreparably broken, marking irreversible transition toward Allied dominance over the home islands. The vast Pacific stretched endlessly beneath the Mustangs, presenting invisible hazards capable of claiming aircraft and crew even without enemy engagement. Fog banks rose unexpectedly, reducing visibility to mere meters and forcing pilots to rely entirely on instruments while maintaining formation integrity precisely. Wind shear and unpredictable turbulence battered wings, producing sudden altitude fluctuations that required constant adjustments to throttle, trim, and flight attitudes simultaneously. Fuel management became critical because slight miscalculations over empty ocean could prevent pilots from completing return flights to the limited airstrips on Iwo Jima. Even minor mechanical malfunctions became deadly, because emergency landings offered no safe alternative across hundreds of miles of open water. Fatigue accumulated steadily, as missions required hours of near-continuous concentration with minimal opportunity for rest, hydration, or physiological relief. Pilots battled heat from engine compartments combined with cold at high altitude, creating extreme thermal stress undermining both alertness and reaction time. Navigational errors compounded risk, because even slight deviations from plotted courses could place aircraft miles off track over featureless ocean expanses. Every instrument reading required scrutiny, as small misreadings influenced survival margins, demanding unwavering mental discipline under relentless operational pressure. The ocean's monotony concealed dangers such as floating debris or sudden sea storms capable of creating deadly downdrafts and unexpected turbulence. Equipment failures presented persistent challenges because volcanic sand often infiltrated engines and control surfaces, decreasing reliability during critical mission phases. Oxygen equipment occasionally malfunctioned, compromising high-altitude performance and endangering pilots already battling fatigue and mental strain over empty skies. Collision risk increased during formation adjustments, as tight spacing and shifting winds made miscalculations lethal in long-range escort patterns. Even experienced pilots faced disorientation caused by horizon illusions, creating subtle yet deadly spatial confusion during extended flights across water with few visual markers. Rescue operations mitigated losses partially, but pilots downed far from base often faced hypothermia, drowning, or delayed recovery despite best efforts from naval units. Black volcanic runways offered limited margins for error upon return, compounding anxiety after 8 hours of endurance-focused operation. Ground crews coordinated rapidly to prepare fuel, maintenance, and emergency support, ensuring aircraft could recover quickly without risking cascading delays across missions. Every sortie represented a balance between risk and operational necessity, demonstrating how extended fighter range transformed exposure to environmental hazards into unavoidable challenges. Despite technological superiority, attrition from weather, fatigue, and navigation claimed dozens of pilots, highlighting vulnerabilities inherent to extreme overwater missions. The high cost of these flights reinforced the ingenuity and resilience required to maintain the operational tempo that ultimately ensured Allied strategic dominance. Lessons learned from these dangers informed subsequent training, emphasizing instrument proficiency, formation discipline, and proactive risk management for future long-range fighter deployments. Pilots developed adaptive decision-making skills, maintaining situational awareness under fatigue while compensating for unexpected meteorological conditions threatening mission completion. Engineering modifications followed, addressing recurring equipment failures to enhance reliability during sustained high-altitude operations over empty ocean expanses. By mid-1945, operational effectiveness exceeded 80%, yet the human toll reflected persistent hazards inherent to unprecedented aviation feats. These costly skies provided the backdrop for both triumph and sacrifice, shaping the evolution of long-range fighter doctrine forever. By April 1945, the presence of P-51 Mustangs over Tokyo signaled a decisive shift in the balance of aerial power. Japanese planners quickly recognized that their remaining fighter forces could no longer contest sustained bombing raids without suffering catastrophic losses. The combination of range, speed, firepower, and disciplined formation flying enabled Mustangs to dictate every engagement with unprecedented control over Japanese airspace. Bomber losses declined dramatically while fighter attrition among Japanese units accelerated, producing a psychological collapse across defensive networks previously considered invulnerable. Imperial doctrine, built around close-range interception and maneuverability, failed completely against aircraft capable of sustained high-altitude performance and instant energy transitions. Lieutenant Saburō Sakai's accounts reflected the shock experienced by Japanese aces confronted with Mustangs outperforming Zeros in every measurable parameter. The escort fighters rendered traditional dogfighting obsolete, creating an operational environment where pilot skill alone could no longer secure tactical victories. Japanese anti-aircraft strategies relied on predictable approaches. Yet American formations introduced flexibility, coordination, and rapid adaptability that defied established defensive assumptions entirely. The psychological effect extended beyond the battlefield, eroding morale among inexperienced and veteran pilots alike, undermining confidence in leadership and operational effectiveness. Even concentrated sorties failed to achieve meaningful interception, as Mustangs dictated altitudes, angles, and timing, making counterattacks predictable and ineffective. Over Tokyo, combined missions integrated escort, bombing, and strike operations seamlessly, demonstrating that long-range fighters could sustain multi-hour sorties with precision navigation and aggressive tactics. Fuel management, drop tank utilization, and disciplined crew coordination allowed Mustangs to escort bombers on 8-hour missions without risk of early exhaustion. The Japanese realized that their air defenses lacked the capability to respond effectively to sustained, coordinated operations designed for simultaneous protection and offensive engagement. Losses continued to mount during every mission, including the destruction of remaining airfields, aircraft, and experienced crews essential for defending the home islands. By mid-April, remaining Japanese forces were incapable of intercepting Allied aircraft effectively, signaling an irreversible erosion of national air power. Strategic consequence extended beyond immediate sorties, because the Mustangs enabled bombers to strike industrial centers without limitation imposed by enemy fighters. This capability accelerated destruction of production facilities, transportation networks, and military depots, directly undermining Japan's capacity to wage sustained war. Allied planners leveraged Mustang superiority to enforce aerial dominance across every operational theater, consolidating victories achieved through combined arms and precision logistical support. By the end of May 1945, Japanese air operations had collapsed entirely, and the myth of homeland invulnerability was shattered decisively. The arrival of Mustangs over Tokyo demonstrated conclusively that industrial innovation, Disciplined training and tactical ingenuity could destroy even the most entrenched defensive doctrines. The strategic breakpoint created by these missions marked the beginning of unchallenged Allied air supremacy over Japan, fundamentally changing the Pacific War's trajectory. Mustangs, once considered tactical fighters, now embodied instruments of strategic decision, controlling skies previously deemed unreachable by single-engine aircraft. Japanese pilots, despite bravery and experience, confronted immutable technological and operational disadvantages, effectively removing them from meaningful combat participation. Air superiority, long considered a fragile balance, was now irreversible in favor of the United States, accelerating the collapse of remaining Japanese defenses. The Mustang's arrival over Tokyo symbolized not only technological triumph but the decisive application of air power that ended Japan's last hope for dominance permanently.